Hi guys, we're back, and this time we're going to talk about the energy budget of the planet, which of course influences the temperature of the planet, or what you might think of as the climate of the planet. So let's get started. All right, so energy budget basics is where we're going to start. So, what controls the global temperature of the planet? Well, temperature is a measure of kinetic energy. That's something that we discussed before. So, if we want to know how much energy is in the atmosphere of the planet, we have to think about how much energy is coming in. And then we also need to think about how much energy is going out. So, it's kind of like your bank account. If you want to know how much money you have in your checking account, you can't only focus on how much money you're getting paid. You also have to consider how much money you're spending on rent and gas and food and whatever else you're spending money on. So we really need to understand both of the incoming energy and the outcoming energy picture to have a comprehensive idea and understanding of the global climate system. Okay, so we're going to kind of break it down and we're going to think about what are the variations in the energy that comes in, and then what are the things that vary in terms of the energy that comes out. And we'll talk about each of those in more detail. But first, I'll just kind of give you this overview. So, first of all, the incoming energy from the sun is something that's commonly referred to as insolation. So, that's kind of a compound word that has the incoming, the solar, and the radiation all together. So insolation is the amount of energy that comes in, and we know that that is not something that is actually consistent. Last week we talked about the fact that, first of all, the Earth, different places on the Earth, don't get the same amount of energy from the sun. So if you're at the equator, you're getting an angle of incoming solar radiation that allows you to get more concentrated energy that's different than the poles. And then we also talked about the fact that there's things that cause just the Earth as a whole to be getting less energy from the sun over time. So this is actually not something that's totally consistent. In addition, there are things that change over time that influence how energy that originally came into the Earth system may either be trapped and held here longer or may be bounced back out into space instead. And so the two dominant factors in that picture are the reflectivity of the Earth's atmosphere, which is sometimes also referred to as albedo, and then the concentration of greenhouse gases that are in the Earth's atmosphere. So we're going to break down these things and talk about them, as I said, in different little mini lectures. But before we get there, I just want to one more time remind everybody that insolation with an O, that's energy that's coming to the planet from the sun, commonly confused with students as insolation, which is something that traps heat. So insolation is energy. It's not something that traps energy. So this is somebody putting like fiberglass insulation in a ceiling. There's other kinds of insulation like in a down jacket or in your coffee cup, but that's not the same as insolation, which is energy from the sun. Okay, so before we get into some of the details, I just want to kind of remind you from before that the energy that arrives here from the sun arrives here in different forms. We talked about the idea of the electromagnetic spectrum, which is this kind of different spectrum or different sizes of these electromagnetic energy waves. And we said that visible light is energy that we can see, infrared energy is energy that we can feel, and then there's other types like X-rays and gamma rays and microwaves. And we said that far and away, the visible light energy and the infrared or heat energy are the two types of energy that arrive at our planet from the sun in the largest quantities. So when we're talking about energy that is coming to the planet from the sun, it is in a variety of types, but it's mostly in this visible light and heat spectrum. And then we said before that not all insolation is equal. So first of all, this can affect different places on the Earth differently, as we mentioned. So first of all, the Earth is curved. It's not flat. And because it's curved relative to the rays of sun or relative to the incoming insolation, That means that if you're in a low latitude position, a latitude close to 0 or close to the equator, you're going to be getting a higher concentration of energy, and so you're going to be hotter than if you're up near the poles where the Earth is curved or leaned back away from the energy that's coming in. We also mentioned that since the Earth is tilted as it moves around the sun in different seasons or in different parts of the year, there's different places on Earth that are getting this bigger dose of energy from the sun, and then other places that are not getting that same dose. So there's kind of a time factor to this insolation picture. It's not always the same in each place, and it's always not the same. It's not always the same at each time. And then we also mentioned the idea that we can measure something that's called the solar constant. And we can think that we have this constant amount of energy that's coming from the sun and hitting the Earth's outer atmosphere. Remember, the solar constant is measured at the Earth's outer atmosphere. But in fact, it's not so constant after all. There's these solar cycles. And so there's actually different amounts of energy that are just arriving here in the first place. And so that's kind of important to keep in mind when we're trying to have this comprehensive understanding of global climate as well as regional climate. Okay, we're going to stop there, and then we're going to jump into more detail about